Hi guys, welcome to my channel AB Online Classes. We are continuing the next next content of the chemical bonding, which is polarization power. So please subscribe my channel. If you don't have subscribed my channel, please subscribe my channel. It is a news channel, and I was inviting you to my world, and I was encouraging you to subscribe my channel because I'm suffering very energy for you for making this content. So today's class is polarization power, which is the part of chemical bonding, and it gives in any competitive exams you will get orders from here, like increasing order and decreasing order related to so many are there, like charge, electronic configuration, size of an anion, size of an cation, like so many are there. For this you should know what is the polarization, what is the polarization power. So many of them don't know the what is the polarization, and what is the factors that affecting the polarization power, and what is helpful in our competitive exams. They will ask like increasing order, decreasing order, but we don't know. We know electronegativity, electron affinity, and size, charge, and so on like that. But polarization we don't know. After seeing polarization, what is the polarization we don't know. We will say that like polar, non-polar, like there's some things there, but that is not equal to here. This one polarization is different and polar different. Polar, non-polar molecules means that those are different from this word. Polarization is different and polar is different. So today's class I'll explain the what is polarization power and the factors that affecting the polarization power. Okay, polarization power. Polarization power. Polarization power. Here I am not writing any definition, but I'll explain what is that. You should keep it in the mind, so it is very helpful to you. So if we see some any covalent characters, some any anion or cation or ionic or covalent bond, here we see that some anion and cation they form same attraction. Like if you see cation like this, if you see anion like this they have some attraction. But we see generally they are attracting each other. Both are attracting, but not at all correct. Not at all correct. Here the cation. The cation means very smaller in size, and where anion is in bigger in size. Okay. And this cation. Cation polarizing. This is the cation. Wait, cation polarizing power. Cation possessing power. Power. This cation has polarizing power, and this anion has polarizability. Polarizability of the anion. Yeah, this both will form same equal to like some covalent character. Covalent character means it is the kind of electron sharing. Kind of electron sharing. They have shared their electrons and they have equal to E same covalent character. Before and after, what has happened? The cation has ability that polarized a near anion, means it will attract, means plus ion will attract the minus ion, means anion. This smaller one attract like this it will attract. Okay, I will write it one minute. I will write in different color. You can understand very easily. Yeah. So like this, like this, like this, like this. It will attract. Like this, it will attract. So this cation we call it as, means here I'm writing the ability of cation having having polarized polarized a polarizing a near anion. So this will have attract, it will attract the anion. So means polarizing, it was polarizing, not attract, we call not an attraction, it was polarizing, like come means it was calling like that. Polarizing the polarizing power of an cation, polarizing power. And anion means I'm writing with different color, you can understand with different. The anion means here I'm saying what is the anion ability? The ability of an anion to get polarized by cation. Polarized by cation. By this you can understand that the cation is polarized, polarizing the anion, and anion is getting polarized by cation. Means it was attract fully to them here, and therefore they form the some covalent character like kind of electron sharing. They form both the sharing and they equal to equal. So now it is the meaning for the polarization power. It is very simple answer. The cation is polarizing the anion, means it was calling, it was attracting the anion, means polarizing the anion, and anion is polarized, means it was have been it was giving, it was attracted to cation, means it was polarized by cation. This polarization power is known as polarization power. And these anions both after polarization they got same covalent characters. Now it's not same, some covalent character will be same, so same electron sharing will be there, so they equal to same size. And okay, now factors affecting polarization power. Factors means some, there are factors like electronegativity, size of an anion, size of an cation, electron configuration, like some factors there. How they affect the polarization, how they act on the polarization. What polarization means? Polarization increases means how they decreases or increases. Like so some rules are there. By this you will get in competitive exams. Orders. They will say that increasing and decreasing orders. You will confuse how, what is the, there will be some molecules and say increasing or decreases. You will go to for confusion. Then if you see this class correctly, you will confirm that no need to say anything. You will get full clarity. So first generally, that is not factors. This is first general one. Before this one, I would like to say something. Yes, small one. Okay, I will explain it on next page. Then you can see. Okay, next page. Here in this page, what I'm going to say is polarization. Polarization power is directly proportional to covalent character. Covalent character and inversely proportional to ionic character. We know that ionic and covalent character are inversely proportional. So here polarization power is polarization power is in directly proportional to covalent character and inversely proportional to ionic character. So by this way only you can directly you can calculate, you can factors means like size, and you already know that yesterday we already said the covalent character has some factors and ionic character has some factors, and ionic character has some rules like ionic character has size. So ionic bond has large cation size and the covalent bond has should have small cation size. Like that, they have some rules for their combination and their character. That rules also uses in this policy because that the covalent character is directly proportional to polarization. So the covalent character should have very small cation size. So polarization also increases when small cation size increases, smaller size increases. When large cation size increases, polarization decreases. Okay, it will affect like that. Okay, now I am say factors affecting is the same as ionic and covalent bond. Difference like that only, but polarization favors for covalent bond because it is directly proportional to covalent character and inversely proportional to ionic character. There are less chances to bond like an ionic bond. They muchly they form so much means largely they form covalent character only. So first one, size of cation. Size of cation. So said right, size of cation. Size of cation. Here polarization. Here writing I am P. P means polarization is directly proportional to 1 by size of cation. Size of cation. If we see here, cation size means cations means if we see cation size increases, it favors for very small cation size only it will form the covalent bond. Large cation size means it will form the ionic bond. Mostly cation size is more than the anion means compulsory it forms the ionic bond. If you see ionic bond is inversely proportional to polarization power and directly proportional to covalent character. Here size of cation if you see size of the cation increases means increasingly. Then what happens? It forms the ionic character. Ionic character means inversely proportional to polarization. So what I've written same that. I've written same thing. Means size of cation increases covalent character decreases ionic character increases. So it is directly proportional to covalent character. So polarization is inversely proportional to ionic. Size of cation increases means it favors for ionic bond. Ionic bond is inversely proportional to polarization. So I'm saying that one. If you remember the rules, if you remember the factors of ionic bond, it is very useful for the polarization also. Ionic bond and covalent bond factors if you use here is very easy to understand the polarization also. No need to by hearting that one. We have to see for some examples. Some examples so that you can see. BeCl2, MgCl2, CaCl2. Wait, 1 minute. Like this, we saw on like this. One minute. Small call. Calcium. So strontium. Sorry. Okay, I'm continuing. Strontium, chlorine 2, Cl2, barium. Barium Cl2. If you see here, from top to bottom, we already know that in any periodic table, top to bottom, size increases. In group, size increases. It's a large one. If you see here, anion is common for all that. All anions are common because chlorine, 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 chlorine. So it's all common. The top to bottom chlorine is common for all that one. So we are not considering anion, only cation. Cation here size is large, large barium, and it is small. For this, it is small. Small. So small means, as we see, it's a large. Large size means it forms cation. Cation means this has low from top to bottom polarization decreases as size increases. Top to bottom polarization decreases. You should know this one, this order. Okay, well, size increases. Okay, then now in period, how it affects the period. If you see how it affects the period also. In period, Na plus, Mg plus 2, Al plus 3, Za plus 4. So cation size decreases here. From like this, cation size decreases. So covalent character increases. Now here, covalent character increases. So polarization. So polarization increases. So ionic character decreases because cation size decreases. It favors for the covalent character morely. Means covalent character increases, polarization also increases. So here you see that very commonly in the groups, top to bottom size increases, so polarization decreases. In periods, side means I'm going to left to right. The size decreasing, so cation size decreasing means covalent character increases, polarization increases, ionic character decreases. Should know that one. Yeah. Next affecting group is size of anion. It is completely reverse for the cation only. We no need to say it briefly because it is completely reversed for the cation. Where their cation size increases means it favors for the ionic bond, so it is inversely proportional to polarization. Here, anion size increases means it favors for the covalent bond, so it directly proportional to polarization. Polarization directly proportional to size of anion because it favors for the covalent character, no. So that's why it favors for the covalent character. That's why it directly proportional. So I'm directly saying the example: CaF2, CaCl2, CaBr2, CaI2. Here, top to bottom, size of anion increases here. Anion increases here, not size of cation. Anion, if you see cation means fluorine, bromine, iodine. Cations are same. Cations are same, no need. We are considering only fluorine, bromine, iodine. No bromine, iodine. So increases covalent character also. Covalent, sorry, 1 minute. Okay. Covalent also increases, and ionic. Ionic character also, ionic character decreases because it's the anion size increases, no. So that's why it is reversible for the cation. Very easily can you find it out. Factor number 3: charge on cation. Charge on cation. How it affects the charge on cation? If you see here, charge of cation. See, for ionic bond, low charge of ion. If you see for ionic bond, how much low charge means charge means what? Cation plus charge. Plus charge means loss of electron. Loss of electron. Loss of electron. How much less electron form, that is more stable. So it is the polarization. Polarization is directly proportional to charge on cation. Charge on cation. So here, for example, we say that Na plus Cl minus Mg plus 2 Cl2 minus Al plus 3 Cl3 SaCl4 plus 4. So if you see here, the charge is increasing. The anion is common, but cation power is increasing. How much size increases? How much size increases? Polarization increases because loss of electron increases means it favors for more for covalent character, but it forms ionic character, but less stable in the ionic character. Ionic bond forms when there is a low charge. So they are saying that charge of cation increases. They are increasing. Increases means they form more charge of cation means it forms covalent character. Covalent matter means polarization. Polarization means less than symbol. Okay, symbol. If you see the second one, means you will get clarity. Charge of anion. Charge of anion. Charge of anion means polarization directly proportional to charge of anion. Sir, why you are questioning like that one? Like that. You said they are both a reverse. Yeah, am I correct? You said both are reverse. But how they are directly proportional to anion? Means, just I'm saying, this is only for charges. Charges increases means they favor for the polarization. More polarization needed for attracting. Loss of electron or gain of electron. Mass of electron, gain of electron, there is more polarization is needed. That so it is not a factor we are using ionic character or covalent character, but it's like ionization energy or ionization energy is also the electron for removing an electron, how much energy we use. So like that here also polarization means it's just combining the two atoms, two ions. It's combining the two ions means here two atoms are attracting and they combining each other. So if anion charge increases means number of electrons increases, extra atoms are increases, it favors for the it has more polarization needed for the combining. Loss of electrons also, it need neutral atom is no need to polarization, less polarization directly. Okay, some example needed for this. Al F3, Al2O3, ALN. If you see here, these are these are F minus, O minus 2, N minus 3. The charge is like here. For this we write it before, like before someone I did. So 1 minute I will correct it like just wait, I'm correcting that one. Okay. Okay, now done. So now how the electronic configuration of cation. Electronic configuration of cation means you can write it directly like if you know jet effect is inversely proportional to size. Jet effect is inversely proportional to size. Means if you see here, NaCl gives rise to Na plus Cl minus, and the CuCl gives rise to Cu plus Cl minus. It is also have plus charge, and copper also have plus charge. But it is from neon configuration 1s2 2s2 2p6. Outer electron configuration has 8 electrons, valence electrons forms. Okay, what about copper? If you see means it forms pseudo electronic configuration. Pseudo electronic configuration means pseudo octet electronic means outer shell has 18 electrons. Copper has 18 electrons in the outermost shell. 1:2, 2:2, 2p6, 3:2, 3p6, 4:2, 3p5. 3d10, sorry, 3d10. So if you see here, one electron after electron losing 1 minute, that's an important one. 1 minute, 1 minute. So the copper, if you see here, this has pseudo gas configuration. So it is formed that one. It forms the covalent character. Covalent, covalent. It forms ionic character. Ionic character. So jet effect. So jet effect of Na plus. Na plus is less than jet effect of Cu plus. So like this, by the polarization or size of an size, by the size you can know the jet effect. Effective means effective nuclear charge with net positive experienced by the electron in multi-electron atom. Means if you see here in a nucleus, there is number of electrons are surrounded with them. Jet effective means most of them. I forgot to tell you that what is the meaning of jet effective. So many are there. So many are there. But in next class, I will explain the what is the jet effective, or I'll create any short video so you know that the what is the meaning of jet effective. Thank you. Thank you. Up to here, I have completed the polarization. Thank you, students. Thank you. I have recently created this new channel, and please encourage my channel. Please to subscribe my channel because I have suffering you for the for this content for this content to know that all this content for you. If you subscribe means it is more helpful for me, and share it to your friends also so they also know that this content who don't know the this content like chemistry content, so they are also helpful for the for this to you and for me also. I'm very thankful for you student. Thank you. Like, share, and subscribe. If you do like for me, I'll satisfy you have satisfied with my content. So do like. If you are unsatisfied with my content, do unlike and share to your friend. So if you like the content, then share to your friends also. They are also helpful for you. And subscribe to my channel. Thank you, students. Thank you, students. Subscribe. Subscribe to my channel. Thank you.